I'm taking finite conductor case. So this is a P point at which magnetic field is to be calculated, and it is shown into the page. Suppose this is point A and this is point B. So it shows the finite case, finite conductor case. Finite conductor case. Okay, of length A to B. Suppose this is elemental length dl. Now connect to P point. Suppose this is r vector, this is z. Suppose this is alpha 1, this is alpha 2, and this is alpha angle. Now this is radial distance rho. Now using Biot Savart's law, it states that dh vector must be equal to ideal cross r vector upon 4 pi r cube. Okay, dh vector means magnetic field due to L, elemental area, elemental length. Okay, dh vector is equal to I into dl vector cross r vector. It is shown here upon 4 pi r cube. Now question arises, what is r vector? R vector is equal to rho a rho because it is the direction this rho a rho minus z a z, because I am interested to calculate this vector. So we know this vector is rho a rho, and this one, because we know in the direction in the upper direction z into az, so it is negative here. Now dl cross r vector becomes dz into az cap cross rho a rho cap minus z az cap. Why dl is dz az cap? Because dl is in the direction of z. This is z direction. Now it becomes rho into dz into a phi cap, because az cross a rho is equal to a phi cap. Okay, now it becomes from equation number 1. Suppose this is equation number 1. It is equal to h vector is equal to lower limit OA. This is OA, and upper limit OB. Lower limit OA and upper limit OB. I rho dz upon 4 pi rho square plus z square plus power 3 by 2 into a phi, because r vector is equal to we know R vector is equal to, sorry, AR cap. R vector, rho arrow, sorry, rho arrow minus Z AZ cap. And the modulus of R vector is equal to R is equal to under root rho square plus Z square. Okay. And R cube is equal to rho square plus Z square to the power 3 by 2. Now let Z is equal to rho cot alpha. Now dz is equal to minus rho cosec square alpha into d alpha. Okay. And for z is equal to OA, means lower limit, OA is equal to rho cot alpha, and OA upon rho is equal to cot alpha. Okay. And it is nothing but cot alpha 1. So alpha is equal to alpha 1 for lower limit. For upper limit, z is equal to OB. OB is equal to rho cot alpha, and OB upon rho is equal to cot alpha, and OB upon rho is nothing but cot alpha 2, and it is equal to cot alpha, and alpha is equal to alpha 2 for upper limit. Now changing limits, h is equal to minus I upon 4 pi alpha 1 to alpha 2 rho square cosec square alpha d alpha upon rho square plus rho square cot square alpha to the power 3 by 2 into a phi cap. Now it becomes h vector is equal to minus I upon 4 pi alpha 1 to alpha 2 rho square cosec square alpha into d alpha upon rho square power 3 by 2 1 plus cot square alpha to the power 3 by 2 into a phi cap. Now h vector becomes minus I upon 4 pi alpha 1 to alpha 2 rho square cosec square alpha d alpha upon rho cube into cosec square alpha to the power 3 by 2 into a phi cap. Now h vector becomes minus I upon 4 pi rho a phi cap alpha 1 to alpha 2 sin alpha into d alpha. Now it becomes h vector is equal to I upon 4 pi rho cos alpha 2 minus cos alpha 1 a phi cap. And this is the h vector for finite conductor case. For finite conductor case. Now consider case 1. Case 1 for semi-infinite. Semi-infinite. It is very easy. Let's draw the figure. A point at origin. Semi-infinite means one point at infinite and one point at origin. Let A is at origin 0, 0, 0 and B at infinite 0, 0, infinite. Okay. So B at infinite and A is at origin 0, 0, 0. So and this is point P. And this is the reference axis. This is the reference axis. Okay. and all angles will be calculated in anti-clockwise direction. So the angle between this point to the reference axis in and anti-clockwise is 90 degree. So this is alpha 1 and alpha 2, because B point is in the direction of reference axis, because B point at infinite, and when point is at infinite, okay, both points are in same direction, same point. A and P are same point when P at infinite. As the distance increases, point merges. We know, अगर हम पॉइंट इनफाइनाइट पे लेके जाते हैं तो दोनों पॉइंट मर्ज हो जाते हैं, है ना, क्योंकि इनफाइनाइट की कोई वो तो है नहीं लिमिटेशन की कितनी वैल्यू रहेगी, इसलिए ए और पी यहाँ पे वो है, मर्ज हो जाएंगे। तो यानी कि जब मर्ज हो जाएंगे तो दोनों में अगर देखें हम, इफ वी सी ए एंड पी आर merges and B is that point, so angle is 0 degree. Okay, angle is 0 degree. Now put the values of alpha 1 90 degree and alpha 2 0 degree. We get I upon 4 pi rho if I get. Second case is infinite, and for infinite case number 2, for infinite conductor. For infinite conductor means both points are at infinite. Both points are at infinite. So B point at infinite means 0 0 infinite. A point also at infinite means 0 0 minus infinite. So this is P, and this is the reference axis. We know this is reference axis. This is B and this is A. 0 0 minus infinite. Okay, all angles will be calculated anti-clockwise. So this angle is 180 degree. So alpha 1 is 180 degree. Now what is the angle of alpha 2? Similarly, as we have found in the previous case, alpha 2 is 0 degree. Okay, so put the values alpha 1 180 degree and alpha 2 0 degree. We get H vector is equal to I upon 4 pi rho cos 0 degree minus cos 180 degree into a phi cap, and we get H vector is equal to I upon 2 pi rho into a phi cap, and